let's go for next topic, that is harmonic oscillator. We have already finished a very primitive topic, that is free particle and particle in a box, and we have seen that uh, the particle is absolutely moving with a constant momentum. But now it's time to change the discourse, and we will introduce the potential. And this potential is nothing but it will vary with the function of x. And the one of the most important system to understand the quantum mechanics and all of quantum mechanics and all the physics is the basically harmonic oscillator. So we have done the harmonic oscillator in our mechanics part. So what is harmonic oscillator? Harmonic oscillator is nothing but simply a spring mass system. That's it. So this is the wonderful example of harmonic oscillator. This is mass m and frequency is omega, or you can just take this spring constant is k, and this is at the equilibrium at, let's say, x is equal to 0. And if we are going to plot the potential, then potential is Vx is equal to, we can write half m omega square x square. And when we are going to plot this potential is absolutely parabolic in nature. They are symmetric, they are parabolic in nature. Classically, what will happen? The classically part, suppose I have this much of energy, the particle will be trapped between these two turning points. The particle is going to trapped between these two turning points. We can also identify what are these two turning point. So at this two turning point, we have Hamiltonian, and Hamiltonian is all about px square upon 2m plus half m omega square x square. At the turning point, the momentum is 0. So you can assume that this Hamiltonian will measure the energy. So for the given value of energy, I can find the turning point, and this turning point x is equal to plus minus, this will be 2e upon m omega square. You can find these are the turning points. So I can just write these are the turning point. One is minus x naught, another is plus x naught. And this value is 2e upon m omega square because px is actually 0. So particle will be rest at these 2 points. But what will happen at the center? At the center, the particle have maximum speed. Why? Because potential is minimum. So kinetic energy is maximum. So at the center, particle have maximum speed. So in term of likelihood, if we want to talk that where you want, where the particle will be most probable, as a classically, what we will see that particle will be rest. So it will be most probable at the turning point, and it is the fastest at the center. So it will be less probable at the center. In another way, what I want to say that passing the delta x time will be less at the center, near about center, and it will be more at the near about turning point. So I we can talk this thing as a probability term also, that where particle is the fastest, means where particle is the spending least time to travel the delta x distance. So obviously you can tell that around the center it has least time, and at the turning point it has uh, absolutely rest. So you can figure it out that particle has most probable at at the turning point. And classically, you can have energy, and that energy is between 0 to infinity. You can see this is positive, this is always positive, so energy is always between 0 to infinity. So you have all infinite value of energy. So these all the classical story we have seen in our classical mechanics or mechanics up to our +2 level and every where we can easily calculate. Now let's see what will happen quantum mechanically. Up to this, if you have any doubt, you can just ask me. Then we will try to solve all this stuff with the operator method in a quantum mechanics. So if you have any doubt up to this, you can just raise the question. Otherwise, I will just go for a quantum mechanical approach of harmonic oscillator. So in a quantum mechanics, obviously, these things are the operators. The Hamiltonian is operator, and we have to solve this operator. So what will be Hamiltonian? The Hamiltonian in a quantum mechanics, H can be written as px square upon 2m plus half m omega square x square. So I have deliberately written in a capital subscript such that we can treat it as a basically operators. What is our first duty? Our first duty is that we will make it dimensionless, and you can see the value of why we are doing the thing dimensionless, because we want to learn the thing in term of numbers. You remember particle infinite box? What we have done? We have made the thing dimensionless. And how you are making the thing with the dimensionless? The using the parameter of a system. Remember, you are using the parameter of a system, and you can make the thing dimensionless. So we are also using the parameter. What are the parameter here? The parameter is mass, omega, and obviously the universal constant for the quantum mechanics is h. So we are using omega, m, and h to make the whole thing dimensionless. So let's see, we are just going to redefine a new operators, and these new operators are dimensionless. So what I am writing, I can redefine my x as root under h cut upon m omega x cap. So x cap is dimensionless. Look at how. What is h cut? H is the dimension of angular momentum. Angular momentum is I into omega. Omega, omega will cancel. M and M will cancel. Root under R square is dimension of length. This is also dimension of length. This is also dimension of length. So this is nothing but the dimensionless quantity. And you can also have this kind of situation. I will talk it later that from where this intuition will come. But right now, we can easily say this has dimension of length. Similarly, we can also have dimension of momentum, and this px can be written as root under m omega h cut, and here we have px cap. So you can again have this h cut is I into omega, and you have easily check out that this is the dimension of momentum. How you can check it? You can have mass omega, h cut is I into omega. And what is I? I is mr square. So this will be m square, let's say r square, omega square. R into omega is something like v. So this will be m into v. So this is dimension of momentum. 100% this is dimension of momentum. You can check it. And now we can have this momentum. And similarly, we have h at something h cut omega. And this is dimensionless quantity h cap. So we have arranged three new operators which are dimensionless. X cap is dimensionless, px cap is dimensionless, h cap is dimensionless. So what we will do? We will just replace all this thing here, and we will figure it out what is the uh, outcome of this particular thing. So let's try to replace all this thing here. If you have any doubt, you can just raise the question, because in this problem, derivation is very important. Unless until you will not understand the derivation, it is next to impossible that you can solve the problem. So obviously derivation in quantum mechanics is always important. So let's try to figure it out. Are you people comfortable?
Yes, sir.
Yes,
Okay.
sir.
Okay. Your silence keep me happy. Okay. So what I am going to do, I will just put all this stuff here. So in spite of h, I will put h cut omega, h cap. H cap is dimensionless. In spite of px, I will put m omega h cut, and this is root will be that gone here. This will be px cap square upon 2m, and plus we have this is all about half m omega square, and x cap can be written as h cut upon m omega, and here is x cap square. The beautiful part is that this m is cancel here, 1 omega 1 m is cancel here, and what we will get, we will get a very nice thing, that is h cut omega h bar, and there is also h cut omega you can take common here, and here we have px cap square by 2 plus x cap square by 2. And what will happen, this h cut omega will cancel. So we have one new operators, and this new operator is h cap, and this thing is x cap square by 2 plus px cap square by 2. And this is a new operator, and which is dimensionless, means now we can work free flowing manner, and we can use the our intuition about number, and we will just try to figure it out how this all operator are uh, going to operate and which kind of thing is there. So this is all about new Hamiltonian. Now obviously look at what we want. It's a very natural instinct. If I have a square minus b square, what I will do, I will just write a plus b into a minus b, such that we can have linear term. So what I will do, I will just try to make it linearize, because I just want to do this all calculation in a very smooth manner by linearizing these all particular stuff. So for that, again you have, if you have a square plus b square, what is your instinct say? Your instinct say you can write this thing a plus ib into a minus ib, because we have complex number with our help, isn't it? So we can use this complex number, and we will again redefine a two new operator, and this new operator is very interesting. And what we have a is equal to 1 by root 2 x cap plus I px cap. So this is my a operator, and again we can redefine a Dagger operator, and this a Dagger operator is all about taking the dagger part of this. This is 1 upon root 2 x cap minus I px cap. And these are the Hermitian conjugate of A. You can see. Now, let's try to figure it out. What will be A dagger A? So we can, again, we are going to define a new operator, and that new operator is all about an operator, and this an operator is nothing but A dagger A. And please, these are operators, so you cannot use them as a number. So this is my Hamiltonian. So let's try to figure it out. What will happen a dagger a? So an operator can be written as, and obviously everything is dimensionless, so you can do multiplication You can do addition, everything you can do in a very free flowing manner. So just let's go for this. N is equal to what is A dagger, and 1 by 2, 1 by 2 I can take together. So this will be 1 by 2 x cap, x cap. So this will be x cap square. IPX minus IPX will be something PX cap square. And I have these two terms x cap minus IPX cap. So you have, sorry, A dagger and A. So you have x cap and IPX cap. So this will be plus I x cap PX cap minus I PX cap x cap. So we have this all stuff. Now, this is nothing but the commutation of x cap and px cap. So we have n is equal to half x cap square plus px cap square, and I can have I by 2 as I can take 2 here, and this is nothing but the commutation of x cap and px cap. Now let us find what will be commutation of x cap and px cap. So we will just try to figure it out what will be commutation of x cap and px cap. And now you can see this is nothing but the h operator. This is nothing but the h cap operator. So I can write h cap operator in term of n plus or minus something this. We will just, when you are going to figure it out, what will be x cap and px cap. So let's try to figure it out what will be x cap and px cap. The commutation between x cap and px cap. So what we have x cap and px cap. What I can write x cap? We can write x cap in term of x. So how we will write it? So this will be m omega upon h cut root under x, and this will be 1 upon root under m omega h cut px. So I can write this thing from earlier notion with what we have taken. So this will be, you can take this m omega is cancelled. So there is 1 upon h cut, and here is x and px. And we know what is x and px. This is nothing but the I h cut. So this can be written as I h cut upon h cut. This is cancel out and we will get I. So yes, this commutation x cap and px commutation is equivalent to I. Obviously it should be dimensionless. It should be dimensionless, and we get this thing. And now I am just putting this particular thing. N is equal to half x cap square px cap square plus I by 2 into I, and this will be minus 1. So I can write this whole thing as a linear operator. So look at x cap square plus px cap square is equal to n plus half. Look at, and this is nothing but h cap. So this is nothing but h cap. So what I have done, intelligently, we just remove the hassle of a square and we get the linear operator, something like linear operator. So we have h cap operator as n plus half. So up to that, if you have any doubt, you can just ask me. Then we will figure it out what is n and how we can recognize this particular n. Okay, so let's try to. So I have h cap operator as half n, sorry, this will be n plus half, and I can write this h cap operator as h on h cut omega is equal to n plus half. And what is h? H is nothing but n plus half h cut omega. Now, this is my Hamiltonian for a harmonic oscillator. Look at how simple it is. All the square term, all the unnecessary square term, we just remove by making the dimensionless thing, and we have this all quantity. And please, this n is Hermitian. Why this n is Hermitian? Because n is nothing but a dagger a, and if you will take the n cap, that will be a dagger a to the power whole dagger, and this will be a dagger to the power dagger is all about a dagger a, that is n. So this is Hermitian operator. N dagger is n, means the eigenvalue of h is always real. The eigenvalue of h or n is always real. Once we will get the eigenvalue of n, we can easily get the eigenvalue of h. So let's try to figure it out. What are these particular n? So let's try to find, let us define n operator have eigenvalue n kit, and this will be n kit. This is our assumption. So from this assumption, I can say this is nothing but the number kit. This is our assumption. But I can make sure that this particular n is a real number. I can make sure that this particular n is real number. It is not imaginary. And this is the symbolic kit associated with this n eigenvalue. So let's try to figure it out. What are the possible value of n? Okay, this n is real, but real can be negative, real can be positive, it can be fraction, it can be all, it can be rational, it can be irrational. There are n number of things. So let us figure it out. What are the property of this particular n? So for that, we will go for the commutation algebra of harmonic oscillator. So let's try to figure it out. What are the property of n, a, and a dagger? Because we have introduced this thing from ourselves. We have introduced this thing for solving the problem. So they are the buffers. So we have to understand what are the meaning of these buffers. The actual thing is all about this h. I am concerned about h, but I just want to know the all behavior of h via n. And if I want to know what is the property of n, I should know what is the a dagger a. So let's try to figure it out. What are the properties of a dagger a and n by the commutation algebra of harmonic oscillator? So let's try to go for commutation algebra of harmonic oscillator. And yes, I have to figure it out what is meaning of that and which type of conclusion we can draw from this thing. At least I can say these are the real number because n is Hermitian. That's it. Now let's go for some algebra part, and let's go for calculating the value of a dagger a. What is commutation of a dagger a? So let's try to figure it out. What are the commutation of a dagger a? Okay, so what is a dagger? A dagger is 1 upon root 2 x cap minus I px cap, and this is x cap plus I px cap, and you can take 1 upon root 2 also. I have just written 1 upon root 2 there. प्लीज म्यूट कर लीजिए, है ना, किसी का अनम्यूट है, इट्स creating lot of noise. Okay, so 1 by 2 will be come outside. What we have? X and x. Second, you have commutation 1 by 2 I am taking outside. And second, x and x commutation, you will take x and px commutation. So plus I x cap and px cap commutation. Then px cap and x commutation minus I px cap and x cap commutation. And last but not the least, I into I is minus, 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 plus. So this will be obviously px cap, px cap commutation. What is xx commutation? 0. So this will be 0. This will be I. What will be x cap, px cap? That is I. What is px cap, x cap? Minus I into minus I. And that will be plus 0. So what we have? So this is also 0. So you have I into I is minus 1. Sorry, this is dot. I into I is minus 1, and I into I is basically minus 1 minus minus plus. Sorry, is that any problem?
No, sir.
No.
Sir, 1
So
by root 2 multiply.
1 by root 2 को हाफ यहाँ कर दिया है ना. So this will be minus 1, and this will be, you have again I into I is minus 1 minus minus plus 1. Okay. So this will be minus 1. So what we will get? We will get this value is minus 1. So this is one of the beautiful thing. A dagger A is minus 1. So similarly, you can get A dagger is plus 1. A dagger is nothing but plus 1. So remember all this thing. So this is very important. At least you can do this thing in your exam. If you have any doubt, you can just ask me. Now, let's go for next step. And this is the most important step. This is the most important step. I am just removing all this thing because I have a constraint of all these small board. So now let us try to figure it out. What will be commutation of N and A? Let us try to figure it out. What will be commutation between N and A? Now, N is A dagger A, and this is A. So how we can write? This will be A dagger A. I can write A here, and second term will be A dagger will be outside. We have A and A. You remember all this formula of commutation. So this will be 0, 100%. And what is A dagger A? Is minus 1. So this will be minus A. What you can write? This is equivalent to minus A. So if we are using this equivalence, so let's try to get, I can write from here to here, NA minus AN is equal to minus A. So what we can write? We can apply the kit on both sides. So what we can write? N A N minus A N N is equal to minus A N. Are you getting all this thing? What will happen? N will operate on N. You will get a small n. So I have keep there. This thing is there. So N will operate on N. You will get a small n. So what you will get? You will get N A N minus A N N kit is equal to minus A N. And this N is number, so I can write it anywhere. And the whole story can be written as N AN is equal to N minus 1 AN. Can I write this thing? Yes, we can write. What is the conclusion? What is conclusion? Can anybody tell me what is conclusion?
lower this.
Capital N is equal to n minus 1.
Hmm?
Eigenvalue minus
Yes,
1.
yes, yes. N minus 1 is the eigenvalue of n with what eigenvector? A n kit. So A n kit is also eigenvector of n with what eigenvalue? N minus 1. So now if we are going to compare it, if we are going to compare it, n n is equal to n n. From we are just going to compare it. Can I say this all thing? So this is not the comparison. So what I can say? I can say n minus 1. I will get n minus 1, n minus 1, isn't it? If I can write this thing, I can write this thing also. So what I can do? I can compare n to n. I can compare n minus 1 to n minus 1. So at least I can say a n kit is proportional to n minus 1.
So it
Are
will
you
be
getting this? Yes? Sorry?
n minus 2. So it may be
Not why n minus 2?
when n is applied on n minus.
Uh-huh. Where is problem? I don't see any problem.
So when n is applied on n minus 1, then we get n minus 2 eigenstate.
Why it will n minus 2? Listen, n will apply on 10, 10n. N will apply it on 15, 15n. N will apply on n, nn. N will apply on n minus 1, n minus 1.
Okay, sir.
Isn't it?
Yes,
देखो
sir.
जो आप पहले पढ़े हो ना उस चक्कर में मत पढ़ो, है ना? मुझे पता है आप कहां से परेशान हो रहे हो. I know this thing. Is that it is clear? Logical, logical. Don't worry. Don't give up logic. Okay? Simple. N will operate on n, then it will give n n. Then if I will transform it n minus 1, then it will be n minus 1. It is very simple. And from this logic, I can say a n is proportional to n minus 1. Means they are parallel. And I am not claiming that they are just exactly same, but I can claim that they are parallel. So why they are the same eigenvalue, isn't it? So using this stuff, I can take the proportionality constant. I can write as a n is equal to, let's say, c minus n minus 1. I can write easily. And now what you can do? We can take a bra of this. When we will take a bra of this, how I can write? N will be n bra, A will be A dagger, and this will be C minus star, and this will be n minus 1. And now I just figure it out what will value of n A dagger A n C minus mod square. There is n minus 1, n minus 1. And here we have taken, obviously it is the eigenstate, so it is orthonormal, it is Hermitian, it is eigenstate. So I have n m as delta nm. So it's very obvious, it's given into our postulates that we should always figure it out for the orthonormal eigenstate. So let's try to figure it out. So now what is A dagger A? What is A dagger A? A dagger A is n.
Yes.
This will be n n. This will be c minus square. And what is this value? Is 1. Because both are same. And n will operate on n. You will get n n n is equal to C minus mod square, and this is again 1. So C minus mod square is n. So at least at this point of time, what we can say? We can say n is always positive number, including 0. You can this number at 0. So at least we can say, because this mod, this is the norms, and norms can never be negative. So this C minus is nothing but root n. So what is the conclusion? The conclusion is a n is equivalent to root n minus 1. And yes, this must be always a real number. So I can say this must be always a positive number, or maybe 0 be also there. So now in the positive number, we have fraction, or we have basically your uh, integers. Only you can have two options: either you have fraction or you have integer. So let us figure it out. If n is fraction, then what will happen? And yes, here we are making the claim n is always positive. This is the claim. So now let us go for the all. If n is fraction, positive but fraction, then let's see what is going to happen. Up to this, are you people comfortable?
Yes, sir.
Okay. Now let's go for next step. And here is a logic. Logic is very important in quantum mechanics, because only mathematics will not satisfy each and everything. Now, let's say if n is equal to 3 by 2, I am just doing as a child, then what will happen? A will operate on 3 by 2, will give us root 3 by 2, 3 by 2 minus 1, that is equivalent to root 3 by 2 half. So A will operate on 3 by 2. This will give you half. Now, if half ket is exist, then if A will operate on half, you will get 1 by 2 and minus half. And here there is discrepancy. You cannot have minus half, because I have chosen that n is always positive. So if we are taking the fraction and we are operating it again and again and making the series, we can get the negative number. So yes, here one more conclusion is that n cannot be fraction. Let's say if n is integer, so n will operate, let's say this will operate on 3, you will get root 3 2. And once a will operate on 2, you will get root 2 1. A will operate on 1, you will get root 1 0, and a will operate on 0, you will get nothing. That's 0. You cannot go beyond this, because if even if it is negative sign, it will, if it is multiplied with the indicate with the 0, it will remain the 0. So here we can make a claim that the minimum value of n can be 0. So n minimum is equal to 0. So just look at thing. I am just coming. Okay. Are you satisfied with this thing, this logic? That minimum value of n can be 0. Okay. So let's go for another story, and that story will be A dagger and N. So this is here I can make a claim that A will operate on N ket. You have root N, N minus 1, but the minimum value of N is 0. So you have lower bound N, and the minimum value is 0 in the harmonic oscillator. So let's try to go for next conclusion. So next we are talking about N and A dagger. So what we have A dagger, A and A dagger. Same method we are doing, repeating it again, and we have A dagger, A plus A dag A A dagger, and you have A dagger here. So obviously this is 0 plus A dagger. A dagger is 1. So this value is equal to A dagger. You can just find this thing. Now again I am just repeating same thing. N A dagger is equal to A dagger. So N A dagger minus A dagger N is equal to A dagger. What I will do? I will again operate N ket on both sides. So what we have? N A dagger N minus A dagger N N is equal to A dagger N. And now you can just figure it out how we can calculate this thing. Now, so what will happen? N will operate on N, you will get a small n. So N A dagger N minus N A dagger N will be A dagger N. You can take this thing in this place. So you have N A dagger N is equal to N plus 1 A dagger N. Now I can again make a claim. What is the claim? That A dagger N is also eigenvector of N with what eigenvalue? N plus 1. Isn't it? Same thing. So now N will operate on N plus 1. You will give N plus 1, N plus 1. So this is the fact. Because if N will operate on N, it will give. So if this holds, then this also holds. There is not any problem. So what we can do, we can again compare the thing. So what is the conclusion? The conclusion is A dagger N is proportional to N plus 1. A dagger N is proportional to N plus 1. So I can write A dagger N is equal to, let's say, C plus N plus 1. And now we can take a bra part of this. Then what will happen? You can write N. A dagger is A is equal to C plus a star. That will be N plus 1. And now we can multiply these two things. When we are going to multiply this thing, what we will get? We will get N A A dagger N is equal to C plus mod square, and here we have N plus 1, N plus 1. It is not visible. I am writing N plus 1 here. N plus 1, N plus 1. Okay, what is N plus 1? N plus 1 is 1. And now we have N A dagger N is equal to C plus mod square. What is A dagger?
N.
And
No, 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 no,
One.
no. Again, you have to figure it out. What will be A dagger? You have
Yes,
information.
sir.
A dagger A is equal to -1. Then A dagger A minus A dagger, sorry, minus A dagger is equal to -1. So A dagger is
n plus 1.
A dagger is equal to A dagger A plus 1. So what is A dagger A? This will be equivalent to n plus 1, isn't it? This is A n plus 1. So please don't do the blunder. So what do you have? You have A dagger A is equal to n and A dagger is equal to n plus 1. These two are different operators. So we can put it here, and once we will write this thing is n plus 1, n is equal to C plus mod square, then you can get C plus mod square is equal to n plus 1. So this is all the story. And finally, we can write A dagger will operate on n. You have root under n plus 1, n plus 1. And the lowest value of n is 0. And now you can operate it after 0, 1, 2, 3. You can find a next level of the calculation. So I am just using this space. So what will happen? A dagger will operate on 0. You will get root 1, 1 kit. A dagger will operate on 1. You will have root 2, 2 kit, and so on. So now we have figured it out what are the basic nature of A dagger, N, and then we can talk each and everything about the Hamiltonian. If you have any doubt, you can just ask me.
Sir, in right hand side, C plus mod square into. Sorry, this is not visible.
कौन सा? ये वाला? This one?
Yes, sir.
ये लिखा ना? यहाँ पर ये नजर नहीं आ रहा है ये? This is mod C square into n plus 1, n plus 1. ठीक है? Are you getting this thing?
Yes, sir. Okay, sir. Thank you, sir.
ठीक है, वो तो यहां से भी कर लोगे ना, जैसा पिछले बार क्या तरह से कर रहे हैं, स्केलर मल्टीप्लिकेशन कर रहे हैं. नाउ लेट्स गो फॉर द फाइनल कंक्लूजन. सो the final conclusion is very simple. N will operate on n. You will get n kit. A will operate on n. You will get root under n minus 1. A dagger will operate on n. You will get root under n plus 1, n plus 1. And what is value of n is equal to 0, 1, 2, 3, and so on. This is the value of n. And now you can see there are only 3 cases can be happen in the nature. Either you will remain at the same state, or you will raise your state, or you can destroy your state. So this will just keep yourself on a same state. This will just try to lower one state, and this will just try to raise one state. And now you can see the discreteness come into picture, because either you have on the n state, and if you are going to operate on the n, you will just lower one state, that will be n minus 1. And if you are operating a dagger on n, you will just go to the next level of state. So why this is called the number state, sorry, number operator. This is called a lowering operator. This is called as raising operator. It will just raise one state, it will just create. Sometime it is also said that annihilation operator and creation operator. So there is two different form. But I am interested into Hamiltonian. Now you can see the Hamiltonian H is given as n plus half h cut omega. And you can easily see that h and n is going to commute. So the eigenvector of n will also eigenvector of h. So what I can say h n will be n plus half n h cut omega. And now n plus half will operate on n kit. You will get a actual eigenvalue of Hamiltonian. And this is the exact matching of the nature, result of the nature. So what you will get, h will operate on n. You will get n plus half h cut omega with n kit. And what is the eigenvalue? The eigenvalue is, or where n is equal to 0, 1, 2, 3. The eigenvalue is h cut omega by 2, 3 by 2 h cut omega, 5 by 2 h cut omega, and so on. And this is the exact value of the matching of the harmonic oscillator at the microscopic level. Again, we can find the energy eigenvalue is the discrete, and the minimum value is h cut omega by 2. And you can just figure it out what are the possible eigenvalues. So this is the minimum value is h cut omega by 2. But classical mechanics, you have any value, any minimum value between 0 to anything. And next level is all about 3 by 2 h cut omega. This is all about n is equal to 0, n is equal to 1. And what are the kit? This kit is basically n 0 kit, and this kit is all about 1 kit. Now the question is that how we will represent this n kit and 0 kit as a part of function. So that will I will do tomorrow. So tomorrow we will just go for different types of problems and all uses of all these things. So just try to figure it out, each and everything. Just go and revise this thing. Tomorrow we will first discuss how we will write the function, and then we will try to solve the different types of problems. Again, postulates is very important. Everything from postulates will come into scan. Okay, if you have any doubt, you can just raise the question. If you have a doubt, you can just go ask the question any from any point.
सर
So
जो
to
आपने
बोलो बोलो
स्टार्टिंग में डायमेंशनलेस किया था वो क्लियर नहीं हुआ एक्स का जो लेंथ का किया था
x का डायमेंशनलेस क्यों नहीं क्लियर हुआ? देखो x को हमने क्या लिखा, यही तो लिखा h कट अपॉन m ओमेगा x कैप, यही लिखा ना. अगर मैं तुमसे पूछूं x कैप का डायमेंशन क्या है, व्हाट विल बी आंसर?
डायमेंशनलेस है
क्यों डायमेंशनलेस है? क्योंकि इसका डायमेंशन लेंथ का है. इसे प्रूफ कर सकते हो इसका डायमेंशन लेंथ का है, तो प्रूफ किया था ना. h को क्या लिखते हो, i इंटू ओमेगा by m into omega. H is nothing but the angular momentum, dimension of angular momentum. So I upon m, I is what? mr square by m. M cancel root under r square, that is length. So it has dimension of length, isn't it? So अगर ये dimension of length है, ये भी dimension of length है, तो ये क्या होगा? Dimensionless होगा. Are you getting this thing?
यस सर
है ना?
Yes,
आप
sir.
करके देखो, खुद करके देखो, मैंने किया था इसमें, मैंने जस्ट बोल दिया था, दूसरे वाले में तो करके दिखाया मोमेंटम का। आप उसी तरह से इसको भी करके देखो। ओके,
Okay, sir.
जस्ट
हेलो
ट्राई
सर।
टू डू ईच एंड एवरीथिंग विथ योरसेल्फ। हाँ बोलो।
सर स्टार्टिंग में जो आपने ए लिखा था वो कैसे लिखा था? 1/√2 एक्स कैप प्लस आयोटा पी एक्स कैप, वो
ये
समझ
मैंने
में नहीं आया।
इंट्यूशन एक, अरे मैंने आपको बताया कि किसी भी चीज को आपके पास x²/2 है और px²/2 है, इसको आप कुछ इस तरह लिख सकते हो, x प्लस आई पी एक्स इंटू एक्स माइनस आई पी एक्स की तरह लिख सकते हैं। नंबर के जस्ट फंक्शन के
यस
टर्म में
सर,
सोचो, लिख सकते हैं या नहीं लिख सकते हैं?
यस सर लिख सकते हैं।
तो यहीं पर
ओके
हमारा
सर।
इंट्यूशन आ गया कि चलो हम किसी चीज को, इसको ए मान लेते हैं, इसको ए टाइगर मान लेते हैं। ठीक है,
ओके सर,
तो इस इंट्यूशन के
थैंक्स
थ्रू
सर।
हमने लिखा, लेकिन हमने दिमाग में ये रखा है कि हम इसे ऑपरेटर की तरह यूज करेंगे। भाई फंक्शन रहता तो आप डायरेक्ट लिख देते, बट ऑपरेटर यूज करना है क्योंकि हमें पता है एक्स कैप और पी एक्स कैप आपस में कम्यूट नहीं कर रहे हैं। एग्रीड और नॉट? सो हमने पूरा का पूरा ओपन किया,
ओके
जस्ट
सर।
इंट्यूशन से देख करने की कोशिश किया, और उसके बीच में आपने देखा कि एच अपने आप आ गया। दिस इज द ब्यूटीफुल पार्ट। जब मैंने ये लिखा था,
ओके
रिमेंबर,
सर।
जब मैंने एन ऑपरेटर को लिखा, व्हेन आई यूज एन ऑपरेटर एज ए डायगर ए, और ए डायगर ए को मैंने इस इंट्यूशन से निकाल लिया। एग्रीड? सो दे आर ऑल आर इंट्यूशनल, और फिर उसको वर्क करके देख रहे हैं कि क्या हो रहा है। एग्रीड? सो ए डायगर ए को अगर मैंने इस इंट्यूशन से निकाला, फिर मैं देख रहा हूं ए डायगर ए करने के बाद बीच में हमारे पास क्या आ रहा है, बिल्कुल एग्जैक्टली आ रहा है एक्स कैप स्क्वायर 2 पी एक्स कैप स्क्वायर बाई 2, और यहां पर -½ आ रहा था, याद है? तो हमारे लिए कितना आसान हो गया, देख लो, इस पूरे चीज को हमने एच कैप लिख रखा है, तो एच कैप आपका एक जस्ट एज अ लीनियर ऑपरेटर मिल गया है ना, जस्ट कोई स्क्वायर नहीं, कुछ नहीं, यहां पर एक्स स्क्वायर है, पी एक्स स्क्वायर है, ये सारा खत्म करके क्या कर दिया हमने, लीनियराइज कर दिया चीजों को। ठीक है,
ओके सर, थैंक्स सर।
ओके, चलो आप फिर से एक बार देख लेना, मैं पहले डाउट ले लूंगा, इसके बाद फिर बात करेंगे। ठीक है, ओके।
Excuse me, sir.
हम्म,
Sir, what will be the answer of the question you gave us yesterday homework?
कौन सा आंसर, कौन सा क्वेश्चन? वो
Where we
निकाल लो ना।
calculate delta
अरे
E
वो
dot
मैंने
delta T.
डेल्टा ही तो मैंने यहीं पर कैलकुलेट कर लिया था, ये तो मैंने कल ही आपको कैलकुलेट करके दे दिया था, और वो होमवर्क बचा कहाँ? डेल्टा टी मैंने कैलकुलेट कर लिया था, क्या कैलकुलेट किया था? 2 पाई एच कैट 4 ई नॉट माइनस ई नॉट, कैलकुलेट करके देख लो क्या होगा। डेल्टा ई के लिए आपको कैलकुलेट करना होगा एक्सपेक्टेशन वैल्यू ऑफ ई स्क्वायर माइनस एक्सपेक्टेशन वैल्यू ई का होल स्क्वायर, ये तो कैलकुलेट पहले ही कर लिया था, इसको कैलकुलेट कर लो। ई स्क्वायर क्या होगा, 4/5 इंटू ई नॉट स्क्वायर प्लस 1/5 इंटू 4 ई नॉट होल स्क्वायर, ये तो कल ही करके दिखा दिया था। अब उसमें जोड़ घटा के क्या आंसर आएगा वो मुझे याद नहीं रहता है, मैं तो एट रैंडम देता हूं। ठीक है, आर यू गेटिंग दिस थिंग?
Okay, sir.
ये सब कैलकुलेट करके खुद कर लो भाई, इसमें मैं क्या बताऊंगा, ये तो मैंने कल ही कर दिया था, ये भी कल कर लिया था, आपको बस ये कैलकुलेट करना था। अभी क्या नंबर आ रहा है, ये नंबर आई एम नॉट इंटरेस्टेड इनटू दिस। ठीक है, दिस इज योर इंटरेस्ट।